Hi, this is kq286 video for homework 2. First I'm showing the Verilog code for the 16-bit counter, and here's the code, and here's test bench. So what I set here to test was when we have no enable and no reverse with reset. In the first cycle, the counter should be 0 because we don't have enable, and reset set to 0, again it should be 0. So when we have the enable signal in the third cycle, it should go to 1 and keep going to 2, and in next cycle we set reverse to 1, it should go back to 1, counter should go back to 1, and when reverse is set to 0, then it should go up to 2 again. So when we disable the enable and we want to test if the reset is truly asynchronous, which is when we set it to 1 out of sync with the clock edge, it should change the counter immediately to 0. So here's my test result. You can see it's as we expected exactly. I'm jumping to the VHDL code. It's implemented for the same function, and actually the test I set up was the same, so the result should be the same. As we can see, here's my simulation result. It's exactly the same as the overall code, and there is no error. I'm jumping to the second question, which is a textbook question. The question I picked was generate mode 8 counter, which is bidirectional. So here's my code in Verilog, and here's my test bench. What I do is so first I set reverse to 0, then the counter should go up to 1, and next cycle go up to 2, and when we set reverse to 1, the counter go back to 1, and set reverse to 0 again, it should go up to 2, and after 5 cycles it should finally go to 7, and after that the next cycle should go to 0 because it's mode 8. So and we set it to reverse again, it should go back to 7 in the next cycle. The simulation result, you can see it's as we expected, and there's no error showing. Here is the VHDL code for the mode 8 counter. It's the same function, bidirectional, and I implemented the same test in the test bench, so we can see the result is same as we expected, and there's no error too.